Good morning, students. Today's new topic in physics is density. So concentrate yourself. We are going to start. Density of a substance is its mass per unit volume. This is the definition. Formula is density is equal to mass over volume. Density is represented by this sign, mass by small m and volume is by capital V, where these are the symbols. This is density, this is mass in kilogram, and this capital V is the volume in meter cube. Density is a scalar quantity. Its unit is kg per meter cube or grams per centimeter cube. Density of materials is very important in daily life, especially for architects, engineers, and chemists. Chemists often make a density determination as a test of the purity of the substance. Substances are made up of different number and composition of the atoms and molecules. A substance can be seen as a gas, liquid, or solid. By comparing mass per unit volume of different substances, we are able to know which has more mass contained inside the same amount of the space. A substance with a lower density than water floats on water. If a substance sinks in water, that means its density is higher than the water. For a pure substance, density is fixed property. That is, its mass is directly proportional to its volume. This also applies to the objects made from a same substance but with different sizes. Density of the water is 1000 kg per meter cube or 1 gram per centimeter cube. Now we are going to learn the measuring methods of density for different types of the material. First, solids. This will be the apparatus. Find the mass of the solid, for example a stone, by using a top pen balance like this, putting a weight on the top pen balance and find the mass. Find the volume of the solid by using a measuring cylinder by first pouring some specific volume of the liquid in it. Note this volume and then put the solid carefully in it. Like this, first pour the liquid and note the volume, then put the solid in it and again note the new volume as well. The difference of the two values will give the volume of the solid. Remember to put your eye at the right level and to read the bottom of the meniscus. I should be at the water level like this. Don't look from up or from down. Use the formula density is equal to mass over volume. Put mass over here, volume here. Solve it on the calculator. Answer will be density of the solid. Next, we are going to learn the method of finding densities of liquids, for example water. Use a measuring cylinder and pour the liquid in it to measure its volume. Find the mass of the dry empty beaker using a beam balance or a top pen balance. Now find the mass of the beaker with the liquid in it. The difference of these two values will give the mass of the liquid. Use the formula density is equal to mass over volume and the result will give you the density of the liquid. Next, we are going to find the density of the gases. For example, air. Air is a mixture of gases. Its density can be found in the following way. The mass of the round bottom flask with its stopper pipe and closed clip is found by placing it on the sensitive top and balance by putting like this. Put it on the top and balance and find the mass. The flask is then attached to a vacuum pump and the air is removed from the flask and the clip is closed. The mass of the evacuated flask, stopper pipe and the closed clip is found by placing it back on the balance. The mass of the air in the flask is found by subtracting the second reading from the first one. The volume of the air removed is found by opening the clip under the water so that water enters to replace the vacuum. The water is then poured into a measuring cylinder to find the volume. And using this formula will give you the density of the gas. Now we are going to learn the method of finding density of regularly shaped objects. For example, rectangle, cylindrical spheres, spherical shaped bodies, etc. Apparatus needed for this is vernier calipers, ruler, balance. Procedure: find the mass m using the balance. Put the object on the balance and read the mass. Determine the volume by taking appropriate measurements and then calculating the volume as follows. For cuboid, measure the length, breadth and height by using a meter ruler or a pair of the vernier calipers. Volumes formula for the cuboid is length into breadth into height. So after finding the length, breadth and height by using a meter rule, put it over here in the formula. This will give you the volume of the cuboid. Mass is already find it out. So put the formula density is equal to mass over volume will give you the cuboid's density. For example, now we are having a cylinder whose density is required. Cylinder's volume's formula is V is equal to pi r square. So find the measurements, radius and height of the cylinder, put it here. This will give you the volume of the cylinder. Mass of the cylinder can be found out by putting it on the top and balance. Then volume and mass can put in the formula of the density is equal to mass over volume will give you the density of the cylinder. Suppose we are required to find the mass of a body which is sphere in shape. The volume for the spherical type bodies is 4 by 3 pi r cube. Find the radius of the sphere, put it here. This will give you the volume of the sphere. The sphere's mass can be found out by putting it on the top and balance. And after finding the volume and the mass, put the values in this formula. This will give you the density of the body that is spherical shaped. A question is here. An experiment was carried out to measure the density of air using a thick walled bottle fitted with a tap. The following results were obtained. Mass of the body containing air is 410 grams. Mass of the evacuated bottle is 409. Mass of the bottle with water is 1150 grams. Density of the water is 1 gram per centimeter cube. What mass of the water was needed to fill the bottle? So here is the evacuated bottle's mass and this is the mass of the bottle with water. So subtract this value and this value. So 1150 minus 409 will give you the mass of the water. B part is, what is the volume of the bottle? Volume of the bottle is equal to volume of the water needed to fill the bottle. So, the volume that is equal to mass of the water over density of the water. Mass of the water we have just find it, that is 741. And density of the water is 1 grams. So putting values in the formula will give you the volume of the bottle. C part is, what mass of the air filled the bottle? So again look at the data. This is the mass of the bottle containing air. This is the mass of the evacuated bottle. So 410 minus 409 will give you the mass of the air. Last part is, what is the density of the air? So we have finded out the mass of the air. Density of the air is equal to mass of the air over volume of the air. So mass of the air is 1 gram and density volume of the air is 741. We have find it out in B part. We'll put in the formula, will give you the answer. And other question is here, how can gas density be used to explain why hydrogen rises in air and carbon dioxide sinks? Very important question. Less dense gas rises above the denser gas. This is the answer. And other question is, objects A and B come from the same substance. If A has twice the size of the B, then the mass of A is twice the mass of the B. And other question is here. Here is some data. What order should be the cards be in? Actually, we are going to find the density of the card. So first okay, here is B is the order 1, 5, 3, 6, 2, 7, 4. So first 1, find the mass of the stone using a mass balance. Then 5, put some liquid into the measuring cylinder and read the level of the liquid. Then 3, put the stone into the liquid. Then 6, flick the cylinder to get rid of any air bubble like this. Then 2, read the new level of the liquid in the measuring cylinder. Then 7, subtract the original volume of the liquid from the volume of the liquid plus the stone. And finally the 4, divide the mass of the stone by its volume to find the density. So this is the total procedure of finding the density of a stone. And other question is here, some students want to calculate the density of a type of the wood. They measure the masses and the volumes of different size samples of the wood. Which graph shows the results? Answer is B. For same substance, mass is directly proportional to volume. This is the answer. The graph should start at the origin. So we will negate this, this and this. And other question is here. 3 objects are cut from the same sheet of the steel. They are different shapes, but they all have the same mass. Which object has the greatest density? Answer will be D. All have the same density because all have the same mass. Since all the objects are made from the same material and have the same mass, then they should have the same amount of the space, volume used to contain this mass. Mass cannot be changed by its shape. And other question is here, A quantity of the gas is in a sealed balloon is cooled down. No gas is allowed to enter or leave the balloon. How do the listed properties of the gas change? Answer will be C. Mass will stays the same. Volume decreases and density increases because sealed balloon is cooled down. When the temperature decreases, the gas contracts. The density will decrease as the volume is smaller but the mass is constant. Remember that the mass of the gas is a constant as no gas is allowed to enter or leave the balloon. The volume of the balloon is not a constant as it can expand or contract. And other question is here. An engineer needs to know the mass of a steel girder which is 20 meter long, 0.1 meter wide and 0.1 meter high. Density of the steel is 8000 kg per meter cube. Okay, volume will be length into width into height. All measurements are given. Put over here in the formula. Use the calculator. This will be the volume of the girder. Density is given. So this is the formula. Density is equal to mass over volume. And putting values in the formula will give you the mass of the girder. And other question is here. You are given a bottle of the milk and asked to find the density of the milk. How would you measure A part, the mass of the milk? By using the mass balance. Second requirement is the volume of the milk. Answer is put the milk in the measuring cylinder and read the level. Last requirement is write down one likely source of the error in your measurements. Answer is flick the cylinder to get rid of any air bubbles. And second precaution is I should be at the level of the liquid to get the reading. So this was the topic. Read it again very carefully and make your notes. Thank you so much.